don't think so. What exactly is work in the context of physics? Doesn't it have something to do with force and movement? Mr. Sharma? That's right. Work involves applying a force to an object and causing it to move. In physics, work is done when a force causes an object to move a certain distance. The formula for work is the force applied multiplied by the distance moved in the direction of the force.
So if I push a wall and it doesn't move, no matter how hard I try, I'm not doing any work. Exactly, because the wall didn't move, no work was done.
Is there more than one type of energy? Mr. Sharma, you bet. Energy comes in various forms, and two of the most important types are kinetic and potential energy. There's kinetic energy, the energy of motion. Whenever an object is moving, it possesses kinetic energy. A speeding car has lots of kinetic energy. The faster it goes, the more kinetic energy it has. We can calculate it with Ke equals 1/2 mv squared, where m is mass and v is velocity. This means that both the mass of the object and its speed play a crucial role in determining its kinetic energy.
What about a book on a shelf? It's just sitting there, not moving at all. It's not moving, but it has energy, right? Mr. Sharma, excellent observation. Even though the book is stationary, it still possesses energy. That's potential energy, the energy of position. This type of energy is stored due to the object's position or state. We calculate it using Pe equals mgh, where m is mass, g is gravity, and h is height. So the higher the object is, the more potential energy it has. This is why a book on a higher shelf has more potential energy than one on a lower shelf.
So, when the roller coaster goes downhill, potential energy becomes kinetic energy. Mr. Sharma, precisely. And as it goes uphill, kinetic energy converts back to potential energy.
Wow, so energy is always transforming.
So if I lift a heavy box quickly, I'm exerting more power compared to someone who takes their time to lift the same box. Power is essentially the rate at which work is done. I'm more powerful than someone who lifts it slowly? Exactly. Power is calculated by dividing the work done by the time it takes to do it. Mr. Sharma, you got it! The faster you do the work, the more power you generate. Now let's put our knowledge to the test. Think about how this concept applies in real life. Imagine you're designing a ramp to move a heavy box. The angle and length of the ramp can affect how much effort is needed. How would you make the work easier? And what tools could you use to reduce the effort required? And how does this affect the power needed? By understanding these principles, you can design more efficient systems. Remember, physics is all around us. From the cars we drive to the sports we play, it's all about the rate of doing work. Keep observing and asking questions. The more you explore, the more you'll understand the world around you.